Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this video, we will be starting our new clustering algorithm in detail, and that is about hierarchical clustering. So I hope that before coming to this video, you already have watched my previous video where I have discussed in a great detail about k-means clustering, as well as we have done the implementation for the same, where we have taken e-commerce based data and we tried to form a clusters based on the spending score, based on the number of transactions, based on the number of invoices customer is generating, right? Depending upon that, we have seen that we will be able to form three clusters via elbow method for the optimal number of clusters per se, and everything all in all we have seen in a very great detail. At the very end, if you remember, we have talked about Silhouette score, which is equally valuable and applicable for the this particular video evaluation also, and the upcoming video also, where we will be talking about the next upcoming clustering algorithm in detail. Okay, so without wasting any time, let's get started the journey of hierarchical clustering now. So now let's deep dive into the hierarchical clustering. First of all, whenever in any of the websites, in any of the standard books, you will hear this term called as agglomerative clustering. Agglomerative clustering. So always remember, this is nothing but is a part of hierarchical clustering also, or you can say it's another term of hierarchical clustering, right? Agglomerative clustering also is a name which is already been given to this hierarchical clustering only. Now, the question is how this clustering algorithm works. Now, let's say we will be having a few data points available with us. It can be of any form. Maybe you will be having these, this, like this. Different points are there, right? Now, what is the problem with k-means that we have covered up in our previous session? The major issue of k-means is that we need to define on a prior basis that what is the value of k, right? We need to define on a prior basis that what is the value of k. Yes, we can define it via elbow method. We have seen it how in an optimized manner we will be able to get the value of k by plotting the graph between the k and the WCSS or distortion score, which we have seen in our previous session. But it's a tedious task, isn't it? Like, we are trying to check out for all the possible data points that we have what is the value of WCSS and the value of k, and whichever value is giving us a optimal value of k, where after which the the value of WCSS is not that much changing. It becomes stagnant somehow. Somehow elbow is forming up. That is what we are saying, that that's an optimal value of k. It means that whenever we are starting our k-means algorithm journey, or I would say k-means plus plus algorithm journey, we need to anyhow define this value of k, right? That is the issue. Now, in order to avoid that, this agglomerative clustering came into picture. It says there is no need to define any value of k, there is no need to define the number of clusters. Bulky, we will try to find out the number of clusters by just plotting a dendrogram. Now, what is that? Let's try to understand here. What this hierarchical clustering will do, or agglomerative clustering will do, it will try to see the nearest points and try to combine those points. For example, let's say we will be having for now P1, P2, P3, P4, P5, and P6, right? I'm just giving some assumptions here, right? Let's assume that the points P1 and P2 are closer to each other. So, see, whatever be the clustering algorithms you will look upon, whether we have talked about k-means, whether today we are talking about hierarchical, or in tomorrow's session we will talk about DB scan, you will observe that in each and every clustering algorithm, the basic funda is the computation of distance only, which can be either done by Euclidean or done by Manhattan. We don't care. By default, the value will be Euclidean only. But here, somehow these distances are able to tell us that, okay, these points are similar to each other. These points have similar pattern in a way, right? So for example, in this case, when I'm saying P1 and P2, they are very close to each other, what this hierarchical clustering will do, it will try to make one connection here. Similarly, let's say we are saying that, or our model is doing a computation, and it will be able to get a sense that now point, let's say, p4 and p5 are closer to each other, so they will be connected together. And let's say the point, maybe you can try to create one more point, or let's say these points are there, maybe we have only single 5 points are there, let me like this. So what is happening is it will try to create a dendrogram corresponding to that, which is kind of a tree based structure, you can say, where what is you're trying to do, you are trying to say that we will be having a point p1 and p2, right? And somehow these 2 points are highly connected with each other because they are having a very, very low distance. So this kind of dendrogram will be built up, which indicates that somehow they are having a similar, or you can say very lowest difference in terms of distance value. So this is nothing but p2. Okay, now you are saying that p4 and somehow I am saying this term as p3 because we cannot have the same points. So let's say p3 and p4 again we will be having, which are again having a p3 and p4. And by the way, on the y-axis we will be having a, let's say, distance value, right? Euclidean distance value for now we are saying. So p1 and p2 they are closer, having some distance value, let's say maybe 2. p3 and p4 are closer and they will be having a distance between each other is, let's say, 3. So this is the by default Euclidean distance I'm talking about. Okay, Euclidean distance I'm talking about. Now, until so far, I think everyone is aware what is the meaning of Euclidean distance. So I don't think there is a need to specifically convey something on top of that part specifically. Now you can easily able to understand that P1, P2, because they're having a shortest distance, internally my model will combine these 2 points and will form a cluster. P3 and P4 will be accepted as one another cluster. Now, what is happening is that originally the number of data points that you have was 5. Can you see? Because we will be having P1 separately, P2 separately, P3, P4 separately, and P5 separately. But now we are just left with, you can consider 3 data points after one iteration, because now we will be having P1 and P2 together in one cluster. We will be having P3 and P4 together within one cluster, and we will be having P5 separately. So that's how the flow is looking currently. Now, let's say you are saying, or your model is saying internally, that these 2 points are now the next closer points, meaning P3, P4. Maybe what it can do internally is either it will try to take a shorter distance out of this P3 and P4 and will say that P5 is very closely related to P4, so it will take the complete cluster, or it can also take a centroid of these 2 points. So what is the new centroid for P3 and P4? And it will take that one and will try to see the distance with respect to P5. Similarly, P1 and P2 new centroid, distance from that with respect to P5. And it is observing that P3 and P4 is somehow closer to P5, as we can see visually as well, as comparable to P1 and P2. So what will happen is further a dendrogram will be elongated, and you will observe that now you will be having a point P5. Let's say they are closely related with the distance value as 5. Again, this is all these values are the hypothetical values. I'm just trying to explain you the core idea behind how this clustering algorithm is working. Okay? Now what is happening is, now let's assume you are saying that I will be having a value of P1 and P2, and now I will be having a complete green cluster, and maybe now they both are very close to each other. So maybe I'll combine these 2 values as well with the distance value of, let's say, 5. So I'm combining these 2 also. So maybe what I can do is, maybe I'll remove these 2 things, right? Because now I just left with only 2 points in a way. One cluster is P3, P4, P5, another one is P1, P2. And I'm saying that now final combination is like this, right? Having a distance value as, let's say, 7. Perfect. So now you will be able to understand that whichever value is having a highest distance, for example, in this case, from here to here, the highest distance is there, right? So what is happening at the end is it will try to form a horizontal line on top of this and will try to count the number of uh, points it is hitting. So here you can see the number of points will be 2. So automatically the number of clusters which my model or which my data point should form is 2 only. Let's say we will be having maybe somewhere 3 hit points. In that case, it will be 3. So what I'm trying to convey here, at the very end, it will try to check that what is the maximum distance of the clusters. Because do you remember the concept between k-means versus k-means plus plus? What we want is that centroids are far from each other. That's where they will be able to form a better cluster. Same knowledge is applicable here as well. What we want is that height wise there will be a maximum distance so that we will be able to form a clusters which are not overlapping with each other. Okay, so this is where we will be able to get an idea via this hierarchical clustering that okay, the value of k should be 2 in terms of the number of clusters I'm trying to signify here, in terms of number of clusters which I want to signify here, right? So in this way the agglomerative clustering works. Here you can see a simple example which I have taken from this implementation. So here you can see I'm trying to do it manually. I'll show you via sklearn, which usually we do via sklearn only because from scratch usually we try to avoid the implementation. But I just want to show you a few things here. That for example here, let's say we have tried to take very random sample points which is applicable. So it's not a standard data which we are picking up from anywhere. It's a random points which we have originated, right, from this random function which you will be able to see in the code as well. Now what we're trying to do is we're trying to find out the distance. It may be Euclidean, it may be yeah, by default it's Euclidean only, and but it can be changed to Manhattan as well. Now what we're trying to do is here you can see we're trying to create a dendrogram with respect to the you can say nearest points which we have. So can you see here, for example, point 11 and 13 they are near, then they are combining with 14, then 19, then 17. We'll try to form a one complete endogram which is combining all the data points. Now if you will try to again map one horizontal line towards the height which is the biggest height from 20 to 100 and I think 150, so you will be able to form two clusters here. So basically what I'm trying to convey here, if I'll again go back to the diagram, you will be able to see that in this case also we will be having optimal number of clusters depending upon these data points that we have is equals to number of clusters is equals to 2 in a way for random data points that we have from I think 0 to 19 means 20 data points which we have randomly generated here, right? So this is the overall idea behind hierarchical clustering. How in terms of sklearn we usually do the implementation, let me try to explain you that as well. But before that, whenever you want to learn about this agglomerative clustering, just open the documentation sklearn.cluster.agglomerative clustering, because you know all the clustering algorithms that we are covering up till so far is available under the package of sklearn.cluster. Now you can see by default it is taking the number of clusters as 2, which is the horizontal line by which we are deciding. Metric is by default Euclidean, which again you can see. And there is one another important thing which you will observe is linkage, which is by default WAD. Let me talk about this parameter also in a lot more detail, what this parameter is signifying. So do you remember I told you that either you will be able to take the difference of centroids of P4 and P5 and then compare with the value of P5 centroids, P3 and P4, and then take the comparison between the P3, P4 centroid and P5. So for example, in this case, how will I get to know that these complete cluster is nearer to P5? So what I told you, either you can take a minimum shorter distance or you can take a maximum distance or you can take a centroid of P3 and P4. This is the parameter which will decide that how the linkage will happen. So if you're saying that I want a linkage via this single, so it will take the minimum of distance between all observations of two sets. If you're saying I'll take complete, it will take the maximum distance between the all observations. If you will say I'll take the average as a parameter, it will take the average of distances. If you will take the default parameter as WAD, it will take the variance. It will take the variance of the clusters, which is the square root of sum of squares, right? So it will minimize the variance of the clusters being merged. By default, it is nothing but is equals to, you will be able to observe, WAD only means it is considering the variance as a parameter, right? So here also I think I have somehow specifically designed and written here with respect to this linkage. And another one which is not mentioned in the documentation is the centroid one also, which I was talking about, where it will take care of the distance between the centroids of the clusters. So any one of them will work. Now, let's try to understand that if, let's say, I want to implement the same code on the similar file that we have worked upon with respect to k-means clustering algorithm. So how will it work? First of all, definitely you have to import that, just like the way you have imported the k-means. So what you're supposed to do, you will say um, from sklearn dot cluster, you will try to import agglomerative clustering. It's done. Now what you can do here is, maybe you can say hierarchical, maybe that is the model name which you can assign. And in this case, you can call this particular agglomerative clustering, where, let's say, as of now, maybe we can take default parameters where the number of clusters will be equals to 2. But anyhow, again, it's a hyperparameter which you can choose via dendrogram, or there are other techniques also to optimize our hyperparameter values, which we will discuss in the upcoming module. But anyhow, you know now that how, with the help of dendrogram also, we will be able to check what is the optimal number of clusters we can pick up. But for now, I'm taking default values, and let's try to fit this particular model on our data set. So we will say hierarchical dot fit, and here we will try to mention df underscore k, which is our data points that we have. And maybe we will try to get the predictions, right? So what we can do here, where is the key means which we have applied? Yep, this is the way we have done, right? So what I'll do is, I'll try to take the similar thing, and what I will do is, I'm just copying the above thing, right? I'm just copying the above thing, so that we will be having a similar pattern here as well, right? So here, number of clusters for now, I am taking it as 3 only, because in the above case also we have taken it as 3, right? Number of clusters we have changed to 3. Now the model name is hierarchical here. Fit underscore predict on df underscore k dataset. Y underscore predicted underscore, you can again say hierarchical, right? And now what we want is, we want to add this hierarchical in our df underscore k value as well. So what will happen is, we will be able to get the predictions, and let's see how well it looks. So here you can see, now we will be able to get the predictions of clusters underscore hierarchical value as well. So here you can see that we have applied our model by the name of agglomerative clustering. We have defined the number of clusters value as 3 here, and the model name is hierarchical. Now what we have done is, we have tried to use fit underscore predict function, which will give us the predictions on the df underscore k dataset. We have stored those predictions in this y underscore predicted underscore hierarchical, and we have tried to create a separate data frame column, which is basically used to give the predictions of this value. Maybe let's try to see the topmost, maybe I'll say 30 records available in my data. So let's see how will it looks like. So somehow I'm feeling that I will be having a similar values available for both of them, right? Maybe what I can do here is, I'll try to change it to number of clusters as 2. Let's see how will it looks like then. Now you can see that in this cluster underscore hierarchical, we will be having the values either 0 and 1. But when we are changing it to 3, somehow I'm seeing here that for this data set, our values are so far similar with respect to what k-means values are giving to us, right? So this is how basically the implementation of hierarchical clustering is being done, right? I hope that this part is pretty much clear to everyone. In the upcoming part of the video, now I will try to discuss about the DB scan. But your task, now what is your task after this session is to calculate the Silhouette score for the hierarchical clustering algorithm, for the, or you can say for the agglomerative clustering algorithm. I hope you all know what is the meaning of Silhouette score, and how basically we will be able to evaluate the Silhouette score specifically for this hierarchical clustering that we have discussed just so far. Is that appropriately same, or there is a difference? If yes, how much is the difference? Which one is better? Now you know everything, that if the score is approximately ranging towards +1, that's a positive value, that's a good thing. and that is what we want for our model? Or is it approximately similar only? Then it means that somehow k-means and hierarchical is working approximately same for this data set, and that is how basically we will be able to deal with this particular clustering part with respect to this e-commerce data set. And even I'll change this file name to e-commerce data set underscore clustering, because in this case we are not even working only for k-means, we are working with a hierarchical also, and we are working for a db scan also. So I think that makes a sense. Okay, so I'll try to share the file and the notes with you all in the study material. Please do refer that in order to implement the below task. With this, I'll see you all very soon in the upcoming. So now I hope that you will be able to get a clear cut idea about hierarchical clustering and its internal working. We have seen its implementation as well. So if you still have any sort of doubt, any confusion, anything which where you are like, "Okay, it is not clear to me," please do try to reach out to me via email, via LinkedIn, and I'll for sure try to resolve your concerns as soon as possible. With this, happy learning to all. Bye bye, everyone. And I'll see you all in the upcoming video where we will discuss the third clustering technique that we have in this course. So please stay tuned for that as well. Bye, everyone, and see ya.